Have you ever wondered, is the weather actually becoming more extreme? This is a question that has been on the minds of many as we witness an increasing frequency of extreme weather events. From raging wildfires to devastating hurricanes, from bone-chilling polar vortexes to scorching heat waves, our planet is experiencing some serious weather mood swings. Many people express concerns about these intensifying weather patterns, and rightfully so. The impact of these changes is not just limited to our comfort or inconvenience. It extends to our economy, our health, our security, and the very sustainability of our planet. In this video, we'll delve into the science behind these weather changes. We'll explore the mechanisms that drive these extreme weather events, and discuss why they seem to be occurring with increasing frequency and intensity. We'll also examine the role of human activity in these changes and the potential solutions we can adopt. Let's uncover the truth behind these extreme weather events. So, what causes these extreme weather changes? Well, let's dive into the science behind it. Weather, in its most basic form, is caused by three key elements: the sun, the Earth's rotation, and atmospheric conditions. The sun, our closest star, is the primary driver of our weather. It heats the Earth unevenly, creating areas of high and low pressure. Warm air, which is lighter than cool air, rises, creating low-pressure areas. In contrast, cool air descends, forming high-pressure areas. This movement of air, from high to low-pressure areas, is what we commonly refer to as wind. Now let's talk about the Earth's rotation. Our planet spins on its axis, an invisible line that runs from the North Pole to the South Pole. This rotation causes something called the Coriolis effect. Simply put, it's why wind doesn't blow in a straight line, but rather in a curved path. The Coriolis effect influences the direction and speed of wind, shaping weather patterns across the globe. Lastly, we have atmospheric conditions. Our atmosphere is a complex mix of gases, water vapor, and particles. Changes in these components, such as an increase in greenhouse gases or a change in humidity, can significantly influence weather patterns. For instance, higher levels of greenhouse gases can trap more heat, leading to a rise in global temperatures and potentially more extreme weather events. But it's not just these elements working in isolation. They constantly interact, creating a dynamic and ever-changing system. For example, the sun's heat can increase evaporation, leading to more clouds and precipitation. Changes in wind direction can transport this moisture to different parts of the globe, resulting in diverse climates and weather conditions. In essence, weather is a complex dance between the sun, the Earth's rotation, and atmospheric conditions. It's a dance that creates the gentle spring breezes, the harsh winter snowstorms, and the dramatic thunderstorms we experience. Understanding these elements is key to understanding the science behind our weather. But how does climate change fit into this picture? Climate change, my friends, is more than just a buzzword. It's a global phenomenon affecting each and every one of us, and it's intricately linked to the weather we experience. When we talk about climate change, we're referring to the long-term shifts in temperatures and weather patterns. Now, these shifts aren't just making our summers a bit warmer, they're leading to more frequent and more extreme weather events. Imagine turning up the heat on a pot of water. The warmer it gets, the more it bubbles and boils, right? The same concept applies to our planet. As global temperatures rise, our pot, the Earth, is boiling over with more intense hurricanes, stronger typhoons, and heavier rainfall. This heating up of the Earth is largely due to an increase in greenhouse gases, primarily carbon dioxide and methane. These gases act like a blanket around our planet, trapping heat and leading to a rise in global temperatures, a phenomenon widely known as global warming. Now, let's talk about how this global warming affects our weather. You see, weather is all about energy. The sun's energy heats the Earth, and our atmosphere, oceans, and land masses absorb and redistribute this heat. When we add more greenhouse gases into the mix, we're effectively turning up the dial on our planet's thermostat. This extra heat in the system can supercharge our weather patterns, making them more extreme. Here's an example. Warmer air can hold more moisture, which can lead to heavier rainfall and more intense storms. On the flip side, in areas where the climate is getting drier, The hotter conditions can exacerbate droughts and heat waves. So when we talk about extreme weather, we can't ignore the role of climate change. It's like a puppet master, pulling the strings behind the scene and amplifying the intensity of our weather patterns. So, climate change is indeed a major player in creating more extreme weather. What happens when the weather becomes more extreme? It's a question that's becoming increasingly crucial as we grapple with the reality of our changing climate. Extreme weather doesn't merely mean we'll need to carry an umbrella more often. It comes with a heavy toll on humans, wildlife, and our environment. When temperatures soar to new heights, we see the emergence of more frequent and severe heat waves. These aren't just uncomfortable, they're downright deadly. From the elderly to the chronically ill, heat waves disproportionately affect the most vulnerable among us, leading to a spike in heat-related illnesses and fatalities. But it's not just about the heat. Droughts, too, are a significant effect of extreme weather. With less rainfall, our lands parch, crops wither, and water supplies dwindle. This can lead to food shortages, escalating prices, and even social conflict over scarce resources. On the flip side of the coin, we have floods. With the atmosphere holding more moisture than before, rains, when they come, are often heavy and relentless. Flooding can cause massive destruction, washing away homes, infrastructure, and sadly, many lives. Let's not forget about the storms. Hurricanes, cyclones, and typhoons are all becoming more powerful and unpredictable. The economic cost of rebuilding in their aftermath is astronomical, and the human cost is incalculable. Wildlife, too, bears the brunt of these extreme weather events. Animals and plants are finely tuned to their environments, and abrupt changes can disrupt entire ecosystems. As habitats transform or disappear, many species face the risk of extinction. The effects of extreme weather ripple outwards, affecting everything from our economy to our physical